So here, we have unrestrained end, unrestrained end. So here we have 0. We say it is 0. So why? Because it's unrestrained, it's wall, it's hinged. WL squared over 11, WL squared over 10, WL squared over 11, this one, WL squared over 16, this one, and WL squared over 11, WL squared over 11. So if we have continuous, then 16, 11, 16, 11, 16, 11, up to go to the last span. Last span 0, 1 over 11, 1 over 10, 0, 1 over 11, 1 over 10, 0 at the wall, 1 over 11, and here 1 over 10, WL squared over 10. Now, what about if we have two span only? If we have two span, let me first this one here. Okay, two span. This one, the up one, this one, column, 1 over 16, 14, 9. 16, 14, 9. Then we have 9, 14, 16. 9, 14, 16. Do you look the coefficients? Okay. Shear force diagram, it is WLN over 2, 1.15 WLN over 2, 1.15 WLN over 2, WLN over 2. What about if we have two spandrel beam? Okay, let's compare this one. Okay. So what about if we have spandrel for 24, 14, 9, 24, 14, 9, then 9, 14, 24, 9, 14, 24, and WLN over 2, 1.15 WLN over 2, 1.15 WLN over 2, WLN over 2. So here we have two span of unrestrained. This one, A. So A, B, C, D, E. So we have shear force, it's the same, WLN over 2, 1.15 WLN over 2, 1.15 WLN over 2, WLN over 2. Now we have 0, 1 over 11, 1 over 9, 0, 1 over 11, 1 over 9. Then we have 1 over 9, 1 over 11, 0, 1 over 9, 1 over 11, 0. So here, this is the example of the continuous beam. Okay, so I think Miss Acer will solve this example. Continuous beam shown in the figure first. So here we have column 4.256. So I'm sorry. 1 minute.
What it said?
I'm sorry. Okay, so now we have three spans. What's the difference between two adjacent spans? So let's solve this one. Solve this one. 5 minus 4.2 divided by 4.2 times 100%. So what's the difference? It is 0.8 over 4.2 times 100. It's equal to calculator 0.8 divided by 4.2 times 100. It is 19. Okay, it is 19. So it's acceptable. So now we can apply our approximation method here. And here we have between 5 and 6 also. Let us check this one, the other one. Let us check. Let us check this one also. So here we have, for example, 6 minus 5 divided by the 5 is equal to 1 over 5 is equal to times 100 is equal to 20%. Okay, it is 20%. So this is also acceptable, acceptable, acceptable. What about live load over dead load? Should be smaller than or equal to 3. So 16 over 12, check. 18 over 15, check. And 24 over 20, check. I think all of them smaller than 3, smaller than 3, smaller than 3. Okay. So draw the bending moment and shear force diagram according to ACI code. Find the maximum positive and negative moment. It's too important. So here we have what is the WU 1.2 dead load plus 1.6 live load for the first span. Then we have the same for the second one and the third one. So the shear force, it's WU ln over 2, 1.15 WU ln over 2, WU ln over 2. Then we have WU ln over 2. And then at the end one should be have the 1.15 WU ln over 2, then WU ln over 2. So Ibrahim, please close the camera. Camera kapat. So here we have the moment diagram. We have column, 3 spans. So column, 3 spans. Here we have this one. Okay, so let's select this one. Okay. This, where's this? This is okay. We have 3 spans. Okay, we have 1 over WLN square over 16. This one. We have WL square over 14. This one, and WL square over 10. Okay, this one. WL square over 11, then 16, then 11, then we have this continuous, and this is symmetric. That's why we should apply the first one, the exterior, because this is the interior. Okay, it's continuous, for example, 4 or 5 like this, but here we have the last one should be, it is the same of the first one. Okay, WL square over 16, 14, 10. 16, 14, 10. Okay, 16 at the end. Now, according to the ACI coefficient method, moment can be calculated as shown figure mu, which is WU ln squared over 16. Here it is negative. Then we have the mu at B. Here we have A, B. Okay, it is, here it is, we have A, then we have B, which is WL squared over 14, which is positive. Then we have at C. So here we have 4.25. So it is, if you look, the dimensions from the face of the supports, not center. This is important. In the exam, maybe I will give you the center dimension and I will give you the dimensions of the columns. So you should take the subtraction of the dimension of the column to get the face dimension like this, 4.256, okay? So we have 4.25. So here you should take the average, 4.2 plus 5 over 2. Okay, this is important. So here MUC left, if we take just only left, then we can make the average also. So it will be 4.2. Okay, it will be WL squared over 10 because it's different, coefficient 10 and 11. So it will be MUC at left, WLN at left. Okay, then we will take the average, take the maximum moment of both sides. So here MUC at right, WLN over 11. So here we have 11. Why we don't have the average LN? Because if we have the same coefficient 10 and 10 here, so we will take the average LN 4.2 plus 5 over 2 or 11 coefficient. But here this coefficient, it is different of this coefficient. That's why we should calculate both of them. Okay, MUCL here, this is the first one, and MUC right, which is the right one, minus 106.36 kilonewton. Now take which one we should take here. We should take the maximum moment, which is 106. Okay, so of both sides. Now we have, this is the MU at C. We should take the moment of the maximum one. But if the coefficient is the same, for example, if we have the case, for example, if we have two span like this, if we have two span, 1/9, 1/9. But this is, for example, 3.4, this is 4. Okay, so we should take the average length. Okay, because the coefficient is the same. Okay, but here in this case, so we should take the moment of the maximum one as the individual. But here, if we have like this, 1/11, and the dimension is the different, so we should take the average length. Okay, this is important. So here we have the MU of C. Then we go to MU at D. This D, that's WL squared over 16, and we have 5 here. Okay, 5, 16. So we have this positive. We have ME at left. Now here it's the same, 11, 10, 5, 6. So we should calculate this part individually and this part individually, and we should take the maximum one. Okay, so here we have MUE at left. Okay, WL squared at 11. So this one, WL squared at 11 and WL squared at 10, and we should take the maximum one, 223. Then we have the F1, which is WL squared over 14, and that length is 6. And here we have over 16. Okay, so this one, it's the same coefficient, but the load is different and the length is different. So it should not say here I calculated WL squared over 14. It's the same of this one. No, it is. This is the has alone or the on the dead load and live load, and here they have the on dead load and live load, and here the dimension is different, 6, and here 4.2. Okay, so MUF, then we have F and we have G. Okay, so we calculated F and G. So F is positive and this is F positive and G is negative. So find maximum moment of positive and negative one. Positive, which one is the negative one? 223 between all of them. For example, negative, where is negative? 44. We have minus 106. We have minus 223. Then we have minus this one, 223.2, negative one. What about the positive one? 73, 50, 44. Then we have 70, and we have 160 for MU at F. So it's 160 maximum moment of the here maximum moment of the positive. And we have, this is the another example. Another example. I think this example, after this example, we have some homeworks. You should solve it. We will open, I think already Ms. Aysar opened this one. And this continuous example, Ms. Aysar will continue with you for the tomorrow. Okay. So, and I can say now, good luck. If you have any question, I can answer it. Please take free if you have any question.
Thank you, Doctor.
هر پرسیارێکتان هەیە هیچ ئەگەر تێنەگەیشتینە پێم بڵێن زۆر ئاساییە باشە. ئەوجا ئەمە چ دەکەین هەفتەی داهاتوو سەد ئەیسەر با کوزەکان لۆ بکە احتیمالە کوزەکان بەنەوەی لۆتان دەکاتن لە مۆدوڵی لۆتان دادەنێ بە تایم پێتە لێ مەسەلەن لە ماوەی سەعاتێک دەبی حەلکەی لۆ بنێری مەسەلەن بۆ نەوعی لۆتان ئەوە دەکە باشە. يعني احتمال تاني إذا كانت عندنا مثلا فلان طلبة أو تسيا أو نوع عجلة ثانية برسيار تاني بك أوش نوع أكتيفيتي كدو الطلبة.
ما مصا استا برسيار حلكين؟
استا برسيار استا بقى برسيار حلكين باش أو برسيار أشبه حلكين. أوكي. أمش حظك حلكين باش. A continuous beam shown in the below figure. Figure one here consists of two spans. Okay, so in the x direction we have continuous span. In the this direction, in the y direction, we have two span. So here it's continuous beam. Okay, continuous beam shown in figure consists of two span. And carries W deadlock livelihood, the left and right end are discontinuous, okay? So, an integral with the columns, okay? Integral with the columns. The dimension 0.3, 0.3. Why, I can ask now, why here it is given the dimension of the column? Why? Because the dimension here, it is given between center and center, right? So we should subtract the dimension of the columns. For example, 5.5 minus 0.3, it will be 5.2. Here will be 5 minus 0.3, 4.7. Okay? So this is the section AA, and this is the section like this. Okay. So answer the following. Draw the shear force and bending moment diagram according to the approximate method of ACI. Okay, so we now this is continuous. We should take the section in the smaller direction. Okay, for example, maybe here we have 100. Okay, it is one-way slab. Maybe we have a 100 meter or 50 meter. But here we should take the shortest path or the short direction, which is 5.5 and 5, okay? And already we don't have any information about this. So how can you solve it? You cannot solve it, okay? That's why we have this section, draw shear force and bending moment diagram, WLN over 2, then 1.15 WLN over 2, 1.15 WLN over 2, WLN over 2, okay? This is the shear force diagram. Okay, what about if we have just only two span? I think here, Okay, if we have two span. If you have two span column. So what's the coefficient? 16, 14, 9, 9, 14, 6. Okay? 16, 14, 9, 9, 14, 6. So what's about WU? What about WU? W dead load, we have live load 1.2 dead load plus 1.6 live load, or 1.4 dead load, which is the maximum. Okay, you should choose it. 1.2 dead load plus 1.6 live load is 36 kilonewton per meter. So now we have LN1, which is 5 minus 0.3, I said 4.7. Then we have 5.5 is minus 0.3 is equal to 5.2. So this is the LN, okay, the first span and the second span. So MU, we say WL square over 16, which is WU, this one, WU, we calculated 36 times 4.7 square over 16. So this is the minus one, okay? So also we have WUL square over 14. This is the positive one. Okay, we have at the C here. What about this one? Here we have 5, here we have 5.5. Can we apply our approximation 1? Yes. Why? Because the difference is 0.5 divided by 5, which is equal, it is 10%. Okay, so we can apply. Also, the live load divided by dead load, it's 1.5. It's smaller than 3. Okay, so this is also our criteria, the second one. So here we have the moment. Okay, but this moment is the same. This moment is the same of this one. It's two span. But the span length, here we have 4.7. Here we have 5.2. Okay. So we should take the average. Okay. We should take the average one. We should take the average moment. Okay. Here we will take the average moment. Where is the moment? Moment at A, we say this one. Moment at B, we say this one. So what about the LN? The LN of the left is 4.7, of the right is 5.2. So if we want to take the moment in this one, so we should take the average LN. Okay, at that time we can say this is the average moment. But in the design, because it is very dangerous one, we should take the maximum one. So to be not failure in the maximum. That's why we can say here 4.7 over 9 minus 88. Here we have 5.2 square over 9 minus 108. So here we take the maximum moment as the previous one. So we can say this is the moment of the C. This is moment of the C. But actually for the practical one, if you go to the side and if you want to calculate the moment diagram for any frame or any beam, so it is you have not any for example time to calculate this one individually. At that time, the code permit us to use the average length. Okay, so but here in academical, so we go to the in the design to take the maximum one. So here we have the M at D 14. Here this is the D, and we have our 16. So we should take the maximum positive moment. Here, what's the maximum positive moment? 69, 56. Okay, which one is the maximum? It is the 69. And what's the negative maximum? Minus 108 and minus 49, so minus 108.16. Now, tomorrow, Ms. Acer will take you to solve some examples and homework. Please try to solve this homework to be ready for the tomorrow. Okay, maybe she will ask you some questions. Okay, please be ready for that. Okay, for example, you have spandrel beam, you have brick wall, spandrel column, beam, you have brick. Okay, So, and here we have, if you have brick wall, and here we have column. If you have brick wall, we have 0, and here we have, I think, WL square over, which one, 24 or 16, over 16, okay? Like this. Do you have any question? Okay, so
This
this is very important to take this one. This is here in the academical solution. If you have student, if you have teacher, if you are a designer, you should take the maximum moment. If you are in the site, if you want to make the practical evaluation for some or checking for some criteria of in the site or the case in the site, so you can take the average. Okay, for example, here we go. This one, it says the average one. Okay, it's actually it is average one. Okay, here 12, 12, 12. So we can take the average one. The code permit us to use the LN average, not maximum. Okay. But where here, if we have the node A, okay, slabs with span not exceed 3 meters, and we have the beam where ratio of sum of column stiffness of beam exceeds 8 at each and span. So this is WL square over 12, okay? This case, WL square over 12, okay? This is over 12. And if we have spandrel, we have this one, 10, this is 11. So here also we can take the average, okay? So but that's why in the site we can use this one. So it's star, this is the star. We can use, if we have two span, we can use 9 instead of 10, okay? Do you have any question?
Dest hoş doktor spas.
That's all. That's why I've sent.
Spas.